Hi guys, this video today is on the inverses of functions. We're going to take inverses and we're going to take functions and talk about what does it mean to have the inverse of a function. So to do that, we're going to talk about a couple things. Graphing it, what does it look like graphically if we have the inverse of a function, as well as algebraically, what does it look like if we have the inverse of a function, and we'll look at a bunch of details of it. So first of all, if you would start off, I didn't label this, but go ahead and label this pentagon. Remember when you took geometry, you did a lot of these things. You did some reflections and translations and that type of thing. So we're going to do a reflection, and we're going to reflect it across the line y equals x. And so this dotted line that I have here is the line y equals x. So do you remember how to do a reflection across that line? So what you're going to do is you're going to, like for instance with point A, if I'm going to reflect it over the line, then A is going to come over here, and you have to go like perpendicular to the line of reflection, and so this is my A prime over here. Whereas if I took maybe point E, I'm going to go the other way because I'm reflecting it over the line there, and that is my E prime. So take a few minutes right now to finish the reflections. Just do all 5 of them and see what you get on your, what the shape looks like when you reflect it. Okay, when you do your reflections of each point, your new image should look like this. And so if you'll notice, it's basically the same shape, right? It's just kind of turned on its side a little bit. So we want to talk about a couple things of what do you notice about the coordinates of each vertex? What do you notice about the shape? Those kind of things. So think about that, look at the diagram, pause the video, and write down a couple things that you might notice about this new shape. All right, there are lots of possibilities that you might have noticed, things that you might have noticed, but 2 of them should be that the x values and the y values are switched and it rotates 90 degrees. So let's just take a look for a minute at the x and y values at what I'm talking about there. So here is my A, which was a point 3,2, and the A prime was at the point 2,3. And E was at 3,5, and E prime is at 5,3. So we are switching the x and the y, no negatives. The negatives are staying the way they are, like the positives stay positive, the negatives stay negatives. But we're switching x and y. And then, of course, the shape does look like it has been rotated, and it has. It has been rotated 90 degrees. Those are both important aspects of inverses. When we talk about inverse functions, they are like that. They will be rotated, and they will switch the x and the y. Okay, let's look at another scenario. What if we have some functions that are more algebraic, like we use in this class? If we have an x squared and we have a square root of x. And notice I put in a plus and minus. Will you do that on your paper? Will you write in a plus and minus square root x? Because that way when we do them, they'll look a little bit more like they're supposed to look. So we need that plus and minus. We talked about that before, that you need that plus and minus to give you the negative half of the parabola. So just to get you started, remember that to graph g of x, you will have in your x column the perfect squares, and then you're going to take the square root of them in the y column. And because I put that plus and minus on the function, then each of these answers is also going to have a plus and minus next to it. So take a minute to graph that on this graph right here. Okay, so your new graph should look like this. And again, the only reason I was able to have both of those points is because I put the plus and minus there. But this is what the new graph should look like. That is my g of x. So take a look at the points on the original and the points that you have drawn, and what do you notice about those points? All right, once again, you should have those same 2 things. The x and the y are switched again, and it does rotate 90 degrees. For example, this point here is 9,3. We can look at our table, is 9,3. And this point over here was 3,9. We also have a negative 9, negative 3, and here we have a negative 3,9. So all of the x and y values, they're all switched. And then as we look at it visually, we can see that it does rotate 90 degrees. All right, inverse functions have a lot of characteristics like these that repeat for every function that you ever come up with, they're always going to have the x and y switched, and they're always going to rotate 90 degrees. What I want to do down here in this space below is discover what are some other things that all inverse functions will do. So you might take a minute to fill in a couple of these. Can you see from the two examples that we've done, are you able to see what are some things that they will always happen? So write down a couple of those if you have them, and then we'll talk about what some more of them are. All right, let's talk about some of these characteristics of inverse functions. We already said that the x and y are switched. That will happen for every inverse function that we ever have. The x and the y will be switched. That will become important and a handy thing for you to remember. In addition, they are all reflected in the line y equals x. And so once again, if we look at our diagrams, each of these were reflected in the line y equals x. That's not accidental. All of the inverse functions will be reflected in the line y equals x. Now, if we are switching the x and the y, we're also switching the domain and the range, right? Because the domain comes from our x values and the range comes from our y values. So if we switch our x and our y, we are also going to switch the domain and range. Number 4, they use inverse operations. And if we just talk about that in sort of a casual way with our vocabulary, we know that x squared and square root of x are inverses of each other. And so they use inverse operations. By the same token, if this was like x plus 5 and this was x minus 5, that might be an indication that these are going to be inverse operations. That they are going to be inverse functions. So any time that we use inverse operations, we have to become aware that we might have inverse functions going on. We need to be careful because sometimes it looks like they're inverses and they're really not, and so we just need to be careful with it, but they will use inverse operations. Now, what I have written down on 5 and 6, they kind of go together. I took some student input from previous years and put these in here, so they are kind of similar. They're the same size, different direction, obviously, because they've been rotated, right? And then they have different end behavior. So back to our example up above here, the parabola is opening up and going towards positive infinity and positive infinity in the y values. Whereas on this one, the end behavior is going towards positive infinity and positive infinity, but in the x values. And so they are different end behavior. They have different end behaviors. And then we have this concept that the inverse and the original function undo each other. And we're going to talk more about that on the other page, but that basically is kind of the definition of an inverse. Let's look at the example that we have up here. If we look at these examples here, we have f of x and g of x. Let's say we consider f of g of x. If we consider f of g of x, that's when we take the g of x and we plug it in to the f of x. So I'm talking about taking this square root of x and plugging it in to the x squared value here. And so if I do that, if I take my square root of x and plug it into x squared, well, don't those two things cancel each other out? A square root and a square cancel each other out, and you just get a basic x. So that's what I'm talking about on number 7, is the inverse and the original undo each other, and so all you have left is an x. And we'll investigate that more on the next page. All right, a couple more things to talk about on this side. The horizontal line test. We know what the vertical line test is, right? We also have the same thing regarding a horizontal line test. So if a horizontal line passes through a function more than once, the inverse is not a function. So this doesn't deal with the function itself, it deals with the inverse of a function. So let's think about a parabola. If we had a horizontal line passing through there, it's going to pass through twice, right? Well, what that means, if it's that is true, that means that the inverse is not a function. Because if we took this and rotated it 90 degrees, then look, it doesn't pass the vertical line test. So the horizontal line test deals with the inverses. A function passes both the horizontal line test and the vertical line test, then it is called a one-to-one function. In that case, every x has only one y, and every y has only one x. And so another way to think about this is, do you remember when we very first learned about functions, maybe even in middle school or whatever, that we would have these table of values and we talk about, okay, well, the 5 goes to this one, but it also goes to this one. And you'd say, well, yeah, but then you have the 2, and the 2 goes to this one and it also goes to this one, right? And it was a question of, okay, wait, is the 5, is that okay? Is that a function? Is the 2, is that okay? Is that a function? Well, here's the deal. If we have a one-to-one function, then there is no v this way or v that way. It is just one-to-one. There is no doubling up on any of them if it's one-to-one. So that's a one-to-one function. And so when we talk about that, that's important because we talk about inverses, then certain inverses are not functions, other inverses are functions. Okay, let's go ahead and turn the page. All right, remember that the inverse switches the x value with the y value. So we're going to talk about now how to do that algebraically. So on the other side, we talked about how to do it on a graph. Now we're going to talk about how to do it through algebra, through like equations. So find the equation that is the inverse of the function and then determine if the inverse is a function. I will say you might want to try to write kind of small, that we're going to try to fit some stuff in here. But the first thing that we want to do with this, and I'm going to list some things out in the margin here. The first thing that we want to do is we want to call f of x y. And the main reason I'm doing that is just it's kind of confusing to have f of x in there with an x in there. So if it's okay with you, I'm just going to call that y instead. All right, the next thing we're going to do is we're going to switch our x with our y. That is one of the characteristics of an inverse. So we're going to switch our x with our y. So I'm going to put my x over here on the left, and I'm going to put y over here on the right. The numbers and all that stay exactly the same. It's just the letters that we're moving. Okay, so then finally, now that we've now that we've switched that, now we need to rearrange everything and solve it for the new y. And so to do that, I'm talking about I need to subtract my 4 from both sides. And then I'm trying to isolate my y, so now I'm going to divide by -3. And this is where I was talking about you might want to write small because I'm running out of space here. So now if I've divided by -3, I'm going to switch sides if that's okay with you. I'm going to have y equals x minus 4 over -3. Or another way you could say that is, first of all, what I want to do in just a second here is change my y back to the f of x notation, but I'm going to call it f -1 of x. That means the inverse of f of x. That -1 power means inverse. Another thing I want to do is maybe rewrite this as a different form. So x over -3, I can call that 1/3 x. And -4 over -3 is going to be a positive 4/3. And the reason I wanted to do that is now we recognize that, don't we? That is a linear. That's just a straight line. Okay, so just to review what we did. We called this y instead of f of x, just to eliminate confusion. We switched our x with our y. And then we just solved this for y, and we worked it out to solve it for y. Finally, we called it f, or f -1 of x. And that's the inverse of x. And that is -1/3 x plus 4/3. So that was part A. Find the equation that is the inverse of the function. That's what you do for that. Part B, determine if the inverse is a function. There are two ways we can do this. We can look at the horizontal line test for the original equation, or we can look at the vertical line test for the new equation. So if we look at the horizontal line test for the original equation, this would be a straight line, right? And it would pass the horizontal line test. Now let's look at this next one. We're going to decide if this passes the vertical line test. And once again, it's a straight line, so it is going to pass the vertical line test. All right, out in the margin here, I wrote down, just so you remember, that f to -1 of x means the inverse function. That's what that notation means. Let's go ahead and look at number 2. We're going to go through the same thing with number 2 as we did for number 1. So remember, the first thing we did is we called this y, and then we switch our x with our y. And now we are going to go ahead and solve it. So I'm going to add 2 to both sides, and I'm going to divide by 5. And finally, I'm going to take the square root of both sides. Remember when we were doing quadratics, and I told you if you're going to solve an equation and you're going to take the square root in the middle of that, you need to have both plus and minus. So we need to have both plus and minus. So now, once again, I'm out of space. I'm going to come up here. I'm going to rewrite this function because the square root of y squared is y. I'm going to call it f of x, actually f to the negative first power of x. And on the left-hand side, I have the plus and minus the square root of x plus 2 over 5. Again, let me just recap what we did. We called f of x y. We switched our x with our y. And then we solved it. Remember, if you take the square root, you have to have a plus and minus. And so we have our answer. The inverse of f of x is x plus 2 all over 5 square root of that. Part B, determine if the inverse is a function. Well, let's think about this. Once again, we can ask ourselves that question, does the horizontal line test, does this first thing pass the horizontal line test? Well, this first function is a parabola, right? No, it does not pass the horizontal line test. We can think about this one. Does it pass the vertical line test? Well, with the plus and minus, if it has the plus and minus there, then no, it does not pass the vertical line test. So the answer to part B is no, it is not a function. And we didn't write that down very specifically on number 1, but we might write down that yes, this is a function. All right, I'm going to go ahead and work through number 3 here. Why don't you take a minute and see what you can do? Follow these steps, 1, 2, and 3 out in the margin. Follow those steps, see if you can redo this one. Pause it here and see what you come up with. Okay, when you simplified your function, you should have come up with one of these two. Either f negative 1 of x is negative 1/2 x squared plus 3/2, or you could have had x squared minus 3 all over negative 2. Those are the same thing, and either one of them would work. I went ahead and put it in this form so that we could see pretty obviously that it is a parabola. But let's review what we did. We called f of x y, and then we switched our x with our y. Then, since it's a square root, we squared both sides. So now we have x squared. We're trying to isolate y. So I'm going to subtract my 3, and I'm going to divide by negative 2, and I end up with this. I do want to call that f negative 1 of x. I don't want you to leave it as a y. Go ahead and change it to f negative 1 of x. But the second step you don't really have to do, but I think it helps to see what it is. And so the question is the new function, or the new, we'll just call it a function, is it a function? And the way we know whether it's a function or not is we could decide, does this pass the vertical line test? Yes, it does. It's a parabola. Parabolas pass the vertical line test. Or we could ask ourselves with the original function, does it pass the horizontal line test? And yes, it does too. This time it does not have the plus and minus. So this function, to start out, is just going to be a half of a parabola. But then when we flip it, it comes out to be both sides. And that happened when we squared it. So yes, this function, the inverse, is a function. Okay, this video is already getting long, so we are going to skip number 4 and move on to the next concept. So another aspect of inverses is that when you do a composition, they basically cancel each other out. In other words, we could say that f of g of x, when we perform that operation, it all cancels out just down to x. Or, actually we should say and, the same thing goes for g of f of x, that if we perform that composition, then that would cancel all the way down to x. So let me show you an example. Let's take a look at this first example. We have these two functions. The question is, are they inverses? Let's think about what that means. Remember, that means that they have, we need to think about what operations are being performed. So this is a fifth root, and this is a fifth power. This is an addition, and this is subtraction. So it seems like there's probably a good chance that these will be these will be inverses of each other. But we want to make sure, because I'm a little bit concerned that the fact that this has an x plus 2 both like inside there, whereas this minus 2 is outside. So we just want to make sure. The way that we are going to make sure is we're going to try to do f of g of x. Okay, so remember, to do f of g of x, we're going to take the fifth root of x plus 2, but we want to plug in for this x, we want to plug in our original g of x. And so we're going to put that g of x here, x to the fifth minus 2, and then we still have a plus 2 on the end. All right, so now when we simplify that, well, before we simplify the outside, let's go inside and simplify what we can simplify inside. And so inside here, we have a negative 2 and a plus 2. These parentheses, the only reason those parentheses were there is because I was showing you we were plugging that in for x. Other than that, they don't have any role. What I'm trying to say is that minus 2 and that plus 2 are going to cancel each other out, and so all we have on the inside is x to the fifth plus 0, but we don't need 0, right? Okay, well, the fifth root of x to the fifth, what is that? That's just x. So yes, it does work for f of g of x. Just to be sure, maybe we should go ahead and try g of f of x, just to clarify, just to make certain that this is what it's going to be. So if we did g of f of x, then I'm going to take my g of x function and I'm going to plug in to that spot where the x used to be. I'm going to plug in my f of x function. Okay, well, I have the fifth root and I have a fifth power. Those cancel each other out. So I have x plus 2, and those canceled, so I don't have a power anymore. And I have a minus 2, so look, they canceled out also. And so yes, they are inverses of each other. They are inverses of each other because whether you do f of g of x or g of f of x, either way, it cancels down to x. Now, do you have to do both? Not really. But if you're on a quiz or a test, it seems like maybe you would want to make sure. So I went ahead and did both of them. All right, we're going to try the same thing for number 2. Once again, we think about what operations are we talking about. We have a plus 3 here, which means we really ought to have a minus 3 over here, which is not the case. And we have a 1 over power x to the negative 1 over here and not. So this doesn't look like it's going to work out. But again, since I'm on a test and my teacher is going to grade me on showing my work, I'm going to go ahead and show this all the way out. So I want to take my g of x function and plug it in to the f of x function. So I'm going to take that g of x, and I'm going to plug it in here. 1 over x plus 3 plus 3. And the question I'm asking myself is, will that equal x? Because if it equals x, it is an inverse. If it equals anything else, it is not an inverse. Does this look to you like it's going to simplify down to x? No, it's not. There's just no way to do that. And once again, if we wanted to check the other way, just to double check and make sure, kind of running out of space here, then I could plug it in the other way. That is, this was f of g of x. I could do g of f of x. Okay, so I could plug in my x plus 3 into the x in my g of x problem. And now this is going to simplify down to 1 over x plus 6. Well, I don't know about you, but that does not equal x. So no, these are not inverses because f of g of x does not equal x. Or you could say g of f of x does not equal x. But essentially, you just have to double check, plug one in, see if it works. If it reduces down to x, it is an inverse. If it doesn't reduce down to x, it is not an inverse. Last problem is a word problem. And here's the deal. When you're doing word problems, don't switch the variables. Like, don't switch your x with your y. You just solve for the other variable. And there are a lot of reasons for this, but mostly, usually when we have word problems, we don't have x and y. We have like base and height, or cost and profit, or different things like that that aren't really x's and y's. They're different letters. And so we're not going to worry about that, because what they are doing, when you do an inverse with a word problem, that's what you're doing. You're solving for the other case. Like, here I have the length, find the height. Well, instead, someone says, okay, can you give me the height if I know the length? Or vice versa, whatever. It's like solving for the other one. So if we look at this problem, what this problem is kind of getting at is, think of an AP test. Some of you have taken AP tests, some of you haven't, but you might know the way they work is you get a score of 1, 2, 3, 4, 5. Now, are there only 5 questions on the test? No, of course not. There's like, I don't know, 200 multiple choices or whatever. So, and then you have some free response, some essay or whatever. So it's more than just 5 points, but yet when you get your grade, they don't say you got 287 right, they just say you got a 4. Okay, how do they do that? Well, they're going to use a formula to determine, given a certain score on the raw score, what did you get on the AP test? That's what this question is basically setting up. They're not calling it AP, and I don't think this is an actual AP formula, but it's the concept. Use that as in your mind as what concept we're talking about. Okay, it says a person's standardized score on a test is given by this function, where x is the actual score on the test. So like I said, that's like, you got 450 points, but the z, so find and interpret the inverse of z squared, z of x, that's what did you get, like a 1, 2, 3, 4, 5. Okay, part A, find and interpret the inverse of x, of z of x. So that means we are looking for z to the negative first power. We're looking for the inverse. Okay, when we do this, once again, don't switch your x and y, because that's just going to make it a little bit more confusing. I'm going to stick with using a z and an x. I might get rid of that x there, but I'm going to use my z and my x. So I have z equals x minus 250 over 40. I want to redo this, so I'm solving for x. So I'm going to multiply by 40. Then I'm going to add 250 to the other side. And so what I have is x equals 250 plus 40z. I'm going to go ahead and rewrite it the other way. Okay, what this is saying, the original equation says this is your AP score if you get, 300 questions right. This says if you got a 4 on the AP test, this is how many questions you got right. So it says find and interpret the inverse. Well, here's the inverse, and what this means is it says the inverse shows what was the raw score given whatever z score you got. So again, you got a 3. Well, how many points did you actually get on the whole test if you got a 3 on the AP? Okay, so question B is we're going to be able to kind of make some sense of that, I think. So we're going to take, if you had a 2.5, what was their actual score on the test? So I'm going to take this equation and I'm going to plug in a 2.5. And remember, I'm using AP as an example, but AP doesn't give 0.5. And this doesn't say AP, that's just my way of helping you understand it. Okay, so if you got a 2.5 on this test, whatever test it is, then how many questions did you actually get right? And so what you're going to do is you're going to now just plug in a 2.5 in for z, and you're going to work it out. And so when I plug in a 2.5, it shows me that the raw score would have been 350. So that's what inverses do for us as far as in the real world. Why do we need this? It just allows you to solve the other way. Now, could have you just plugged your number in here instead? Sure, you could have done that. But this just gives you kind of a shortcut, because a lot of times it helps to be able to rearrange these to make a shortcut to do the other way. You guys know I teach physics. We do this a lot in physics, where we'll solve for the other variable, and then you just have to plug it in and you get a quick and easy answer. All right, we will be working on inverses, and this is the last lesson in this unit. So we are now ready to start working on inverses and then reviewing for the test.